Did I mention to you that the pH of neutral water is 7? Well, that's a lie. And in fact, I have to tell you this funny story. About a decade ago, I was asked to give a lecture to a bunch of AP chemistry teachers, and they had come during the summer, and we had gotten together, and I was going through a variety of lectures I do for my freshman chemistry course. And we got to this lecture on pH, and I was delivering the lecture, being nice and bored, and I got to the point where I said to them, okay, so now let's talk about what the pH of water is. And I showed them what I'm going to show you now. And when I was through, what I had just shown them was that the pH of neutral water was 7 sometimes, but sometimes it was 6, and sometimes it was 8. And I looked at these folks, and they looked at me, and there was this look of, I don't know, somewhere between deep sadness, that a fundamental truth had been ripped from their hearts, and utter shock that they had been teaching something wrong for several decades. The truth of the matter is that the pH of water is rarely 7. It's usually something else. But because it turns out that under the most common circumstances that we work with, the pH of water is 7, it's just become the sort of default idea. Now, why is it that the pH of water isn't 7 if I've just shown you that the Kw value is 10 to the minus 14? The math seems to be pretty clear. If that's 10 to the minus 14, then the pH and the pOH of pure water are 7. The answer is because this value right here is 10 to the minus 14 at room temperature. Oh yeah, that's right. This is thermodynamics. Equilibrium constants, according to the Van't Hoff equation, remember the Van't Hoff equation, that's that thing where you look at the ratio of the log of the K values is equal to the delta H over R, and then this ratio of temperatures, 1 over T1 minus 1 over T2. In other words, this may be 10 to the minus 14 for my K value at room temperature, but it's going to be something at other values. And the second that number stops being 10 to the minus 14, that number stops being 14, which means that the two numbers added together here stop being 7. So I'm going to show you some data, and this data is something that you could calculate from the Van't Hoff expression. If you know the delta H for the reaction, then you can find out the Kw at 10 to the minus 14 for room temperature, but now let's go down to ice water temperature. Let's go up to just below boiling, brand new Kw, and as a result, brand new pHs for pure water solutions.